Hello students, today we are going to solve another problem using our simplex method. The question is minimize z equal to x1 plus 2x2 plus 3x3 subject to 2x1 minus x2 plus x3 greater than or equal to 4, x1 plus x2 plus 2x3 less than or equal to 8, x2 minus x3 greater than or equal to 2, x1, x2, x3 greater than or equal to 0. Yesterday we have a two variable problem. Here we have three variables x1, x2, x3. In case of two variables we can solve it graphically also. Here graphical solution is not possible. Now there are two greater than or equal to constraints with the positive RHS. Earlier we have used the bigger method or two-phase simplex method for such questions. Now using dual simplex method, irrespective of the positive or negative RHS, we can solve the same problem. First we have to write all the constraints of less than or equal to form with the positive or negative RHS. Right side positive ആണോ നെഗറ്റീവ് ആണോ എന്ന് നോക്കാതെ നമ്മളെല്ലാ കൺസ്ട്രെയിൻസിനെ ആദ്യം ലെസ് ദാൻ ഓർ ഈക്വൽ ടു ഫോമിലേക്ക് കൺവേർട്ട് ചെയ്യുന്നു. അതാണ് നമ്മൾ ആദ്യം ചെയ്യുന്ന കാര്യം. I am going to write the constraints less than or equal to form. Multiplying first constraint by minus sign on both sides. Second is already less than or equal to form. Third can be multiplied by minus sign on both sides. In that procedure we write the constraints of less than or equal to form. Here we have written all the constraints less than or equal to form. Then we add slack variables to each of the constraints and write the problem in standard form of this dual simplex method. Three constraints are less than or equal to form. Adding first slack variable x4 to first constraint, x5 to next one, x6 to last one, and rewriting the objective function including the slack variables. We can write the problem to apply it in the dual simplex table. Here we have written objective function including the slack variables x4, x5, x6 with the coefficient 0. Minimize z എന്ന് തന്നെ അത് എഴുതാം. Subject to first constraint x4 ആഡ് ചെയ്തു equal to -4 എന്നാക്കി. സെക്കൻഡിൽ x5 ആഡ് ചെയ്തു, അവിടെ റൈറ്റ് സൈഡ് പോസിറ്റീവ് ആണ്. തേർഡിൽ x6 ആഡ് ചെയ്തു, റൈറ്റ് സൈഡ് നെഗറ്റീവ് ആണ്. All the variables given satisfy the non-negativity restrictions and our slack variables x4, x5, x6 also satisfy the non-negativity restriction. Then we can write the dual simplex table. We move to dual simplex table. Basis, then B, P1, P2, P3, P4, P5 and P6. In the first stage, the slack variables are in the basis, which are the slack variables x4, x5 and x6 with the coefficients 0. x4, x5, x6 with the coefficients zeros and b values -4, 8, -2. And then we can write the equations. The first equation -2x1 plus x2 minus x3 plus x4 0 x5 0 x6. Similarly we can write the next two equations. I have completed the first table. The net evaluations are similar to the cost coefficients since the cost corresponding to x4, x5, x6 are zeros. All the net evaluations positive here. That is a peculiarity of dual simplex method. Now there are negative b values. Then select the least among the negatives. -4 and -2 negative. 8 consider ചെയ്യേണ്ട കാര്യം പോലും ഇല്ല. Then we select -4. Minimum of first we have selected minimum of -4 and -2 negative bi's equal to -4. അത് select ചെയ്തു. Then we have to evaluate maximum of net evaluation divided by selected row entries. Selected row is the first row. Only negative ratios. Maximum of 1 by -2. First row which are calculated. Then 2 by 1 is positive. No need. Then 3 by -1. സെക്കൻഡിന് കറസ്പോണ്ടിങ് ആയിട്ടില്ല. തേർഡ് പൊസിഷന് കറസ്പോണ്ടിങ് ആയിട്ട് നെഗറ്റീവ് ആണ് 3 by -1. Then we will not write 0 values. Next 3 values are zeros. Then we have to find the maximum of 1 by minus 2 and 3 by minus 1, which is same as minimum of positive minimum 1 by 2 and 3. Minimum is 1 by 2 and it is corresponding to the first position. First position corresponding to selection gitti. That means x4 goes out of the basis and x1 enters the basis. Change the basis to x1, x5 and x6. Coefficients x1 in 1, x5 in 0, x6 in 0. Then we have to make this point 1. Therefore divide by minus 2. Minus 4 by minus 2, that is we get 2. Minus 2 by minus 2. 1 by minus 2 minus 1 by 2. Minus 1 by 2 plus 1 by 2. 1 by minus 2 minus 1 by 2. Then 0. Then 0. Then we have to make all the other entries in that column zeros. Here it is easy. Last column contains 0 already. Then last entry of that column. Then second entry is 1. Therefore subtract the new first row from the old second row. 8 minus 2, 6. 1 minus 1, 0. 1 minus 1 by 2. 1 plus 1 by 2. 3 by 2, 2 minus 1 by 2, that is also 3 by 2, 0 minus 1 by 2, 1 by 2, 1 minus 0, 0 minus 0. Last row is same, minus 2, 0, automatically minus 1, 0 minus 1, 1, 0, 0, 1. Transformations on the last row. Then we have to calculate the net evaluations. Here there is a coefficient which is non-zero. Therefore we have to calculate. First we calculate Z. Z equal to 1 into 2, 0 into 6, 0 into minus 2. 1 into 2 equal to 2 is the answer. X1 in the basis, X5, X6 in the basis. No calculations needed. Then for P2, 2 minus 1 by 2. 2 plus 1 by 2. 2 into 2, 4 plus 1 by 2. That is 5 by 2. All these entries are to be correct because we need in the calculations maximum of net evaluation divided by selected row entry. If this is correct, then only we get the selection correctly. So be careful in the calculations. For P3, 3 minus 1 by 2, that means 3 into 2, 6 minus 1, 5 by 2. Again 5 by 2. Then 0 minus 1 by 2, 1 by 2. 0, 5 by 2, 5 by 2, 1 by 2, 0, 0. That are the values. Now we have to find whether there is a negative, only one negative in BIs. Therefore we select that. X6 goes out of the basis. It leads to the conclusion. X6 goes out of the basis, and to find which variable enters the basis, we calculate maximum of BI negative or no. This is 0 corresponding to first 0. Here we have last row 5 by 2 divided by minus 1. Net evaluation 5 by 2 divided by selected row entry, last row entry minus 1. Then 5 by 2 divided by 1. അതിൻ്റെ ആവശ്യമില്ല. അപ്പോൾ ഇതിന് എഴുതണ്ട. Net evaluation by selected row entry if it is negative. Then 1 by 2 divided by 0. No need to write. Then 0, 0. Zeros എഴുതത്തില്ല. Zeros എഴുതത്തില്ല. Positives എഴുതത്തില്ല. Negative values എഴുതത്തുള്ളൂ. Only 1 ratio, and that corresponds to minus 1, that is P2. X6 goes out of the basis and X2 comes into the basis. X1 in the position of X6, X1, X5, and in the position of X6 we write X2. X1 1, X5 0, X2 goes to 2. Then what is the change in last row? The selected entry is minus 1. Multiplying by minus sign, it becomes 1. 2, 0, 1, minus 1, 0, 0, minus 1. Then for the second row, we have to multiply each element of the new R3 by 3 by 2 for second row and subtract it, or multiply the old by 3 by 2 and add 6 minus 2 into 3 by 2. ഇവിടെ ആകുമ്പോൾ ആഡ് ചെയ്താൽ മതി. 2 into 3 by 2. 2 into 3 by 2, 2 ക്യാൻസൽ ചെയ്തിട്ട് 6 minus 3, that is 3 എന്ന് ആൻസർ കിട്ടും. 0 minus 0, 3 by 2, 3 by 2 കൊണ്ട് മൾട്ടിപ്ലൈ ചെയ്യുക, ആഡ് ചെയ്യുക. 3 by 2 minus 3 by 2, 0. 3 by 2, 3 by 2 കൊണ്ട് മൾട്ടിപ്ലൈ ചെയ്യുക, ആഡ് ചെയ്യുക. 3 by 2 plus 3 by 2 എന്നായി. That is 3. Then 1 by 2, 3 by 2 കൊണ്ട് മൾട്ടിപ്ലൈ ചെയ്യുക, ആഡ് ചെയ്യുക. മൾട്ടിപ്ലൈ ചെയ്യുന്നത് 0 ആണ്, അതുകൊണ്ടൊന്നും കിട്ടാനില്ല. അടുത്തതിലും അങ്ങനെ തന്നെ 1 തന്നെയാവും. 0, 3 by 2 കൊണ്ട് മൾട്ടിപ്ലൈ ചെയ്യുക, ആഡ് ചെയ്യുക. That is 3 by 2. Then for the first row, there is a minus 1 by 2 in the corresponding position. Multiply with the 1 by 2 all the last row. Oh, yeah, it is easy to use the new last row. Multiply by 1 by 2 the last row and add 2 and add 2 plus 1 by 2 into 2, 2 plus 1, 3. 1, 0. Minus 1 by 2 plus 1 by 2, 0. 1 by 2 minus 1 by 2, again 0. Minus 1 by 2, then operated with the 0, therefore it is minus 1 by 2. 0 minus 0, 0. Multiply with the 1 by 2, minus 1 by 2, and add minus 1 by 2. Then the net evaluations are Z equal to 1 into 3 plus 2 into 2, 4 plus 3, 7. Z equal to 7. X1 in the basis, X2 in the basis, and X5 also in the basis. Net evaluation zeros. Then for P3, 3 minus 1 into 0, minus 0 into 3, minus 2 into minus 1. 3 plus 2, that is 5. For P4, 0 minus minus 1 by 2, that is 1 by 2. Next one is 0. Other one is also 0. Hence 1 by 2. For the last column, 0 minus minus 1 by 2, 1 by 2, plus next one 0, next one 2. 1 by 2 plus 2, that is 5 by 2. Now all the BI values are positive. There is no way to proceed, and that means the dual simplex method ends, and we can write the solution as minimum of Z equal to. മറ്റൊന്നും ആലോചിക്കാനില്ല, ഈ ടേബിളിൽ കാണുന്നത് തന്നെയാണ് മിനിമം. We have introduced x4, x5, x6 with the cost 0. Therefore we get the value of the original objective function. Here objective function already in the minimization form. Therefore nothing to do with the objective function. Min Z equal to 7. At we are given x1, x2, x3. x1 equal to 3 here, x2 equal to 2 here, and x3 equal to x3 not in the basis. x1 in the basis, x2 in the basis. x3 not in the basis means x3 equal to 0. And in the given problem, only x1, x2, x3. All the other not. x5 equal to 3, but it is not needed here. We write the solution for the given variables x1, x2, x3. Min Z equal to 7 at x1 equal to 3, x2 equal to 2, x3 equal to 0. That is a solution. അപ്പോൾ ശ്രദ്ധിക്കേണ്ടത് ലെസ് ദാൻ ഓർ ഈക്വൽ ടു ഫോമിൽ എല്ലാ കൺസ്ട്രെയിൻസിനെ ആക്കുക. പോസിറ്റീവോ നെഗറ്റീവോ RHS ആവാം, എല്ലാം ലെസ് ദാൻ ഓർ ഈക്വൽ ടു ഫോം ആവണമെന്നാണ് നിർബന്ധം. We only add slack variables like this. Then write the simplex table as usual. Then all the net evaluations will be non-negative. അപ്പോൾ സാധാരണ മെത്തേഡ് പോലെ പ്രൊസീഡ് ചെയ്യാൻ പറ്റത്തില്ല. Then we take the least of the negatives among B values. B valuesലെ negatives least എടുക്കുക. Corresponding to that selection, calculate maximum of net evaluation by selected row entry. Here in the first table, net evaluation divided by first row entry, maximum of only for negative ratios, and that maximum value determines which variable enters the basis. Replace the basis and proceed like in the usual simplex method. അപ്പോൾ സെലക്ട് ചെയ്യുന്നത് BISന്റെ മിനിമം ആണെന്നുള്ളത് ഒരു കാര്യം. പിന്നെ എൻ്ററിങ് വേരിയബിളിനെ തീരുമാനിക്കാൻ മാക്സിമം ഓഫ് നെറ്റ് എവാലുവേഷൻ ഡിവൈഡ് ബൈ കറസ്പോണ്ടിങ് റോ എൻട്രി ഓൺലി ഫോർ നെഗറ്റീവ് റേഷ്യോസ്. ഇത്രയും സൂക്ഷിച്ചാൽ ആൻസർ അറിയാം. കുറച്ച് പ്രോബ്ലംസ് കൂടെ ചെയ്യാൻ തരാം, നിങ്ങളത് ചെയ്യുക.